Aspirin is an irreversible inhibitor of your cyclooxygenase enzymes because of this chemical group right here circled in blue. This is an acetyl group, and when this group comes into contact with your cyclooxygenase enzyme, we undergo a process called acetylation, and this irreversibly destroys the cyclooxygenase enzyme. So, something that you should be aware of is that once aspirin, or acetylsalicylic acid, which is the chemical name of aspirin, undergoes acetylation, the acetyl group actually binds to the serine amino acid of your cyclooxygenase enzymes. Now, unfortunately, this is actually quite an important concept for some exams, and some exams also want you to know that it comes specifically on the 530th location, amino acid location, so serine 530. Aspirin, as an irreversible inhibitor, is also considered a suicide inhibitor because once this acetyl group is donated, we're left with salicylic acid. And this molecule right here is going to be essentially useless. So it's as if the molecule committed suicide in order to inhibit the cyclooxygenase enzyme. Now, aspirin is the only irreversible NSAID, but what about all the other NSAIDs like ibuprofen, ketorolac, naproxen? These are considered competitive inhibitors. And what I mean by this is, here let's say we have our cyclooxygenase enzyme. And the cyclooxygenase enzyme is going to have an enzyme binding site, right? So let's imagine that this is the binding site. Do you know what the substrate that usually binds to this enzyme binding site is? It's arachidonic acid. When we have any other NSAID, we are competing with arachidonic acid for this enzyme binding site. Now, this is not considered irreversible because if, say, this NSAID binds to this binding site, the NSAID is not stuck there forever. It can easily be dislodged because the forces keeping the NSAID binding to the binding site are weak forces that are non-covalent, whereas aspirin covalently modifies the serine residues of cyclooxygenase 1 and 2. Now, the irreversible effects of aspirin become particularly relevant in low-dose aspirin inhibiting cyclooxygenase 1 specifically and causing blood thinning effects. In another video, I talk more about the differences between low and high dose aspirin, so if you want to know the details, you should watch that video. You may already be aware that since aspirin blocks cyclooxygenase enzymes in platelets, it's going to block the secretion of thromboxane A2. Now, this is a very interesting molecule because what it's going to do is going to act on the platelet that secreted it and other platelets to increase the expression of this glycoprotein, GP2B3A. This glycoprotein is responsible for binding to other platelets. Therefore, when its expression is increased on platelets, it's going to allow for its aggregation. Here's a GP2B3A molecule binding to a fibrinogen, and then the fibrinogen binds to a GP2B3A on another platelet and causes aggregation. Since aspirin prevents this from happening, aggregation is going to be inhibited, and therefore blood is not going to clot the same, which is going to be good for patients that have high cardiovascular risk because it's going to prevent myocardial infarctions and strokes. The reason why this mechanism is so effective is because once a cyclooxygenase enzyme in a certain platelet is bound, this platelet is completely void. It cannot be used to contribute to aggregation anymore. Platelets have a lifespan in the blood of around 7 days, and so for aspirin's effects to wear off, new platelets have to be produced. And this is why if we're going to perform a surgery where we have a high risk of bleeding and therefore we need the blood clotting function, we have to stop aspirin at least 7 days before that surgery.